Life on Earth. The origin of life is one of the great mysteries in the universe. To determine the origin of life, scientists are investigating the problem in several different ways. Some scientists are studying life on our own planet. Some scientists are seeking out life or fossil life on other planets or moons in our solar system. And other scientists are trying to detect life in other solar systems, either by measuring life's effects on the atmospheres of distant planets or by measuring artificial radiation by radio signals that may be produced by advanced life. Today we take for granted that we live among diverse communities of animals that feed on each other. Our ecosystems are structured by feeding relationships like killer whales eating seals, which eat a squid, which feed on krill. These and other animals require oxygen to extract energy from their food, but that's not how life on Earth used to be. Thus far, the most fruitful approach has been to examine life on our own planet. However, even in our own backyard, it is difficult to determine life's origin because it begins at least 3.5 billion years ago. We know that life began at least 3.5 billion years ago because that is the age of the oldest rocks with fossil evidence of life on Earth. These rocks are rare because subsequent geological processes have reshaped the surface of our planet, often destroying older rocks while making new ones. Nonetheless, 3.5 billion year old rocks with fossils can be found in Africa and Australia. They are usually a mix of solidified volcanic lavas and sedimentary rocks. Other scientists which study life on other planets is found a planet like our Earth, not too hot and not too cold, has formed. What chemistry must develop to yield the building blocks of life? In the 1950s, the iconic Miller-Urey experiment, which zapped a mixture of water and simple chemicals with electric pulses, demonstrated that amino acids, the building blocks of proteins, are easy to make. Other molecules of life turned out to be harder to synthesize, however, and it is now apparent that we need to completely reimagine the path from chemistry to life. The central reason hinges on the versatility of RNA, a very long molecule that plays a multitude of essential roles in all existing forms of life. RNA can not only act like an enzyme, it can also store and transmit information. Remarkably, all the protein in all organisms is made by the catalytic activity of the RNA component of the ribosome, the cellular machine that reads genetic information and makes a protein molecules. This observation suggests that RNA dominated an early stage in the evolution of life. They also reveal carbon isotope signatures that appear to have been produced by organisms that lived when the sediments were deposits. Assuming that key problem is solved, we will still need to understand how RNA was replicated with the first primitive cells. Researchers are just beginning to identify the source of chemical energy that could enable the RNA to copy itself, but much remains to be done. If these hurdles can also be overcome, we may be able to build replicating evolving RNA-based cells in the laboratory, recapitulating a possible route to the origin of life. Being an environment devoid of oxygen and high in methane, for much of its history, Earth would not have been a welcoming place for animals. The earliest life forms we know of were microscopic organisms or microbes that left signals of their presence in rocks about 3.7 billion years old. The signals consisted of a type of carbon molecule that is produced by living things. If one analyzes the genetic information in a variety of modern organisms living on Earth, one can begin to group and separate organisms based on their common properties. This same process can be applied to all organisms that has led to the three large domains of life: bacteria, archaea and eukarya. Humans as well as other complex mammals are part of the eukarya group. If one traces the genetic information in organisms in all three groups, it appears they have common ancestor or at least ancestors that share a common set of traits. In either case, it appears the earliest form of life in the tree of life bear thermophilic or hyperthermophilic organism which means they lived in system composed of hot water. So I hope you learned something in this video. If you have any question, please type in comment section and share with your friends and family to support me. So see you again in next video. For then, bye bye.